middle of all that. I kind of wanted to get through with the systems of equations and then do 8-4. And there's really some practical reasons for doing 8-4. And one of those is just because it helps you practice your algebra skills. But the other reason is if you are going to move on and take some higher math courses, you will need this skill when you get to some of those courses. So I'm going to basically give you an introduction to decomposition of fractions today. It's not going to be as complicated as it can get because I'm just going to we're going to do the basic ones to show you the process. And then when you get into some of the higher order math classes like linear algebra or Cal 2 or something like that, you will be prepared to do decomposition of rational fractions if you have to. So I'm not going to make this difficult. I'm just going to give you the very most basic type problems that you need to solve. All right, so I'm going to share a screen with you. So this is called partial fractions. And that's what we're going to decompose a rational expression into partial fractions. So the first thing I want you to do is to go back in time and recall when you have to simplify, or let's say we want to add these two rational and we want to get a common denominator. So hopefully you'll remember that the first thing you want to do, oh, let me hit record. I'm sorry. I got to record the class. Someone asked me to record this class and I almost forgot. So the first thing we want to do is remember how do you add rational expressions? So we add rational expressions by getting a common denominator. So over here to the side, I'm going to write the least common denominator for those two expressions. And so we have to have the x minus 3 and the x plus 1. And so remember how we're going to get our common denominator for each side. So I'm going to leave a little room here. So we look at our common denominator over here. And in this first expression, we say we have the x minus 3, but we don't have the x minus 1. So we would have to multiply by x plus 1 in the numerator and the denominator to get that common denominator. So to get a common denominator, you've got to get an equivalent fraction, which means we multiply the numerator and the denominator by the missing factor. And over here, we're missing an x minus 3. So that's what we have to put. Okay, so now we have a common denominator, and now I can combine this all with the same common denominator. So it doesn't matter what order you have those in. So I have 3x plus 3 plus negative 2x minus 5. So that gives me x, I'm combining like terms, minus 2 over x minus 3, x plus 1. Hopefully we all recall, all you're doing basically is getting a common denominator because you're adding fractions. So the common denominator just happens to be two binomial expressions. And you get your equivalent fractions by multiplying the numerator and the denominator by whatever factor is missing. So that was what we did back in some earlier algebra. We didn't do it in here, but you did it in your algebra course in high school or algebra 2, or you did it in math 100, depending on what you took. So hopefully you've seen that, because what we're going to do today is we're going to reverse that. We're going to take an expression that is in this form, and we're going to figure out how to break it back up into the partial fractions. So actually, that would be, if we didn't know what those were, we would put a over x minus 3 plus b over x plus 1. And then we have a process that we go through to solve for a and b. And in the end, you would see that a is 3 and b is -2 if we did the partial
And then
fraction.
he's like,
Miss
"Oh,
Rachel.
the shower floor." And I'm like, "Oh, is this
Shouldn't it be +5, not -5?
I'm like,
Or -5?
you know, I'm having trouble keeping up with all of
For before you simplified
And
it.
he's like, "Ask Rusty." He said that the material was in. I'm like, "Well, that's not a shower repair."
That's 6,
I was
yeah.
thinking like,
Yeah.
in my mind,
Is that right? Is that right? 2x plus 6. I don't know where I got 5, and I sure don't know where I got -5. So -2 times -3 is plus 6. So that would be 9. 9.
Miss Rachel, you're breaking up. Or
I am.
maybe I couldn't understand you. I'm sorry.
Well, I'm going to tell you that we've been having some internet trouble here today, and I decided that I actually recorded my class this morning because the internet was dropping in and out. Are you able to hear me better now, or
Yes, ma'am.
are you still breaking up?
Yeah, I can hear you now. Sometimes
Okay.
it goes in and out.
Okay, just let me know if you don't, like, if I start breaking up, I can repeat something. Okay.
Thank you.
Okay, you're welcome. All right, so did I correct my math error there? So let me go back over what I was saying, and if I start breaking up, just tell me. So I got my common denominator and got my equivalent fractions, and I multiplied, and I mismultiplied over here. -2 times -3 is +6. Thank you for whoever caught me on that. And so I ended up with x plus 9 over the common denominator. And I guess what I was saying after that was, what we're going to do is take an expression like this and figure out how to break it up into its partial fractions. So these are the partial fraction. This is the partial fraction decomposition. And we have to come up with what is A and what is B. So the purpose of this basically is to do adding rational expressions backwards. So we're basically undoing the common denominator and getting the partial fraction breakdown of this expression. Okay, so I'm going to just go through these slides just a little bit. So we start with a rational expression, and then we want to write it as a sum of two simpler fractions or partial fractions. And so an equation containing the sum of those on the right-hand side is called the partial fraction decomposition. And when you hear someone say partial fraction decomposition, all they're doing is breaking a rational expression down into its partial fractions. So it's not as complicated as it sounds. We're going to basically we're not going to do the long division. If the numerator, the highest degree in the numerator is bigger than the highest degree in the denominator, you just use long division or synthetic division. So you don't have to decompose it, it'll decompose itself. But if the degree in the numerator is less than the degree in the denominator, that's when we're going to write it into partial fractions. And if we have an x square, a binomial squared, that's called a repeated linear factor. So you're just going to have one extra term to solve for. These three are the only ones we're doing in here. You can do quadratics too, but you have to write a linear term, bx plus c, on top of the quadratic, and you have to solve for those that way. So we're not going to do these in this class. So we're just teaching you how to do the composition, how to do the decomposition, and then in a linear algebra or a Cal 2 or another higher level math course, this would be taught to you in more detail. But they would want you to know the basic procedure for getting a breakdown of the partial fractions. So if I wanted to find the partial fraction decomposition for this, what I would do is I would say, well, this is going to equal to sum A over x plus 1 plus sum B over x minus 2. And if I could figure out what A and B are, then I would have the partial fraction decomposition. So what we do is we figure out what the least common denominator is, and it's always going to be this denominator, x plus 1 times x minus 2. So step number 2 is we're going to multiply both sides by the least common denominator. So I'm going to multiply this side by x plus 1, x minus 2. So basically I'm multiplying both sides, but I'm multiplying every term. So I'm just going to go ahead and write this twice over here. So I'm multiplying all the terms, both sides of the equation, by the least common denominator. Now I'm going to simplify. So over here, the whole denominator will cancel out, and you have 8x minus 7. Over here, the x plus 1 cancels out, so I have a x minus 2. And over here, the x minus 2's cancel, and I have b times x plus 1. So I found the least common denominator, which is always going to be this denominator on the left. Multiply both sides by the least common denominator and simplify. Now, this is where I part ways with the book. At this point, the book has another method for solving these that I don't like. I like my method. So I'm going to teach you my method. And if you want to look at the book's method and do it that way, that's up to you. But I do it this way. So step number 4, I let x equal, and see, I have an equation, so I can plug in any x value I want to. So I'm going to let x equal a number that will eliminate either A or B. So let x equal a number trying to write neat. Let x equal a number that will eliminate either A or B. So how can I eliminate A? What number for X could I plug in and get rid of that whole term? Anybody want to weigh in on that?
Would it be 2?
Yes, exactly. And if I wanted to eliminate B, I would use -1. Good. So I'm going to let X equal 2 right here. So everywhere I have an X, I'm just going to plug in a 2. And now I'm just going to go through and do the math. So this is going to be 16 minus 7 is 9. This is going to 0. So the whole thing cancels out. And then 2 plus 1 is 3. So I just have 3B over here. So you divide by 3. And we get B equals 3. So we know that B is 3. So we know part of our partial fraction decomposition. Then I'm going to let X equal -1. So this is going to be -15 over here. And -3A. And this one's going to 0. 0 times B is 0. Divide by -3. And I have A equals 5. So what that tells us in a nutshell is 8x minus 7 over x plus 1 times x minus 2 equals 5 over x plus 1 plus 3 over x minus 2. That is the partial fraction decomposition. Now, when you're doing your practice problems in your textbook or you're doing some of your problems in MathHub, it might just ask you to find A and B. So you wouldn't have to write out the partial fraction decomposition or type it out. But if it asks for it, then you just type it in like that as a fraction, a partial fraction. So that's the process. It's not a hard process. There's really 4 steps. Once you let X be a number that will eliminate A or B, step 5 is just to solve. Solve for A and solve for B. So it does get a little more complicated than that, but basically those are the basic decomposition problems that we do. So I want to move on to the next screen, and I want you to try to do this one on your own, and then we'll do one with the repeated linear factors. So you try this one and see if you can come up with the partial fraction. So remember, you want to set it up with your A over x plus 1, B over x minus 2. And I'm going to just let you have a few minutes to work on that one. If anybody finishes, you can type your answers in. Okay, so if you get fractions, let's see what we do with those. I believe those are correct. So let me go back over here and work on this. So I know some of you might not be finished, but I've got to do some work. So I'm going to go ahead and just do some of the work here. And I write all this stuff out. And y'all, the reason that I do is I'm very apt to be like, I'm sort of ADD. So I'm likely to just be talking and or paying attention to something else. And I'm just going to make a mistake. So if I write it out, it's a lot easier for me to find my mistake. So multiply both sides by the least common denominator. And then simplify. So when I simplify, I cancel this denominator completely out. And then over here, I can cancel out the x plus 1. And over here, I can cancel out the x minus 2. Okay, now I need to choose an x value. That will eliminate A or B, or basically both, but one at a time. So the first one I'm going to choose is x equals 2. So I get 1 equals, that goes to 0, 3b, divide by 3. So b equals 1/3. And if I let x equal -1, now this one goes to 0, and I have -5 equals -3b, divide by -3, and I get b equals 5/3. So I could write it like this. I could write, oh, what did I do? This is A, I'm sorry. A. -3a. So A is 5/3. So I can write it like this, 5/3 over x plus 1, and then 1/3 over x minus 2. Over, yeah. So if I made those denominators into a fraction, put it over 1, and if I multiplied by the reciprocal, that would be 5/3 times 1 over x plus 1. So that would actually be 5/3 times x plus 1. So it would be nicer if we wrote this as 5/3 x plus 1 plus 1/3 x minus 2. If you multiply by the reciprocal here, you're going to multiply by 1 over x minus 2. So you're going to have 1/3 times x minus 2. It's just nicer to type it like this. And I can't guarantee you that MATLAB won't make you do that. So that's the reason I wanted to go ahead. I mean, this is the right answer. It's just a complex fraction, and we try to avoid those for answers. So just multiply by the reciprocal and get it in that form. So before we move to the repeated linear factor, that's two of those, and any of those problems, that's how they're going to work. Okay. Are y'all okay with what I did with multiplying by the reciprocal and writing that as just not as a complex fraction? Okay. Are these a little easier to do than some of the other things we've done? It's a pretty straightforward process. You kind of just do the same thing for every one of these. Now, I'm about to give you one that's a little different, but this is as hard or as complicated as I'm getting in this class. So I'm not doing any of the quadratics in the denominator. I am going to do one that has repeated linear factors. Uh-oh, y'all don't want to do those probably. Okay. So what this does have a quadratic, but the thing about it is it's in the numerator. So how we decompose this is we have a over x minus 1 plus b over x plus 3 plus c over x plus 3 squared. So we just have to add this extra term in because we have a binomial squared. So we have to list the individual factors plus the squared factors to get the decomposition. So you can't just list the x plus 3 squared. You got to list this middle term here with just the x plus 3. Because actually, if you wrote it out, you could actually have a part that was just the x plus 3. So that only difference is when I have a squared term, I have to write the linear term and the square term of that factor. All right, so to solve this, I'm still going to use the same procedure. I'm still going to multiply both sides by the least common denominator, which is x minus 1 times x minus 3 squared. Plus 3, sorry. So each one of these has got to be multiplied by that same thing. You have to be kind of slow and careful with these. They're not hard, but you can make a mistake pretty easily. All right, so let's simplify. That whole denominator will cancel out. So I have that left over. Over here, we have an x minus 1, so I have a x plus 3 squared. Now over here, this one cancels one of those, and I have an x plus 3 left over. So this is going to be b times x minus 1, x plus 3. So only one of those is going to cancel out. So I'm going to have an x plus 3 left. And then over here, both of them cancel out. So I have c x minus 1. So now I need to choose my X values that will eliminate one of those terms. So let's start with X equals -3. -3 will make this one go to 0 and this one go to 0. So y'all check my math out here. I think that side's -12. Y'all check that out for me. This one goes to 0, and because of that, any one of those terms is going to make that go to 0. So you're going to have -4c. So c is going to equal 3. Again, not hard, just long, kind of tedious, but it's not hard, I don't think. Now I'm going to go to the next page, and I need to recopy this down. So I just recopied my equation, and this time I'm going to let x equal 1. So if I let x equal 1, I'm going to eliminate the c term and the b term. So this one's going to be 0 and that one's going to be 0. So I'm just going to let that go instead of writing all that out again. So when I let this equal 1, 1 minus 1 is going to be 0. So 1 minus 1 there, 1 minus 1 there, both of those are going to 0. So 3 plus 17 plus 12. $32 equals, and that's 4 squared, so that's 16a. So a equals 32. Now, what happens now is I ran out of numbers that would eliminate one of the terms. So we are out of numbers. I'm going to write this out just so you'll have it.
Miss Rachel,
Yes, that's
how did you
2.
get?
Is that it? Sorry. I said a equals 2. I don't know why I wrote 32.
Okay, that's what I was asking.
Okay, thank you. She can't read this. I am gonna read it out loud, but I thought I would just finish writing it first. Okay, so we're out of numbers that will make one of those factors 0. So we wanna substitute the A and the C that we have already, and then just choose anything we want for X. Does that make sense? I'm going to, put another slide in, just so I don't have to jumble this up. Okay, so we're out of numbers that will make one of the factors 0. So I'm gonna go back to this equation right here, to the, 3x squared plus 17x. I'm gonna make this a little bigger so I can see. Okay, so I'm gonna substitute what I got for A and what I got for C. So I got 3 for C and A was 2, is that right? Yeah, C was 3, A was 2. And the reason I have to substitute those in is because I'm gonna pick an X value, and I can't have all these variables in that I don't know. So I have to plug in something for A and B, so I can solve this for C when I choose an X value. So I can solve for B, I'm sorry. Okay, so I ran out of numbers that made it 0, so I gotta find some other way to solve for B. So I substituted A and C, and if I picked if I can pick any X value, that's gonna take care of all the X's, and I will be able to solve for B. So it doesn't matter what you pick for X, and I am gonna make a suggestion. If you let X equal 0, if we haven't already used 0 for any reason, if you let X equal 0, things get simple, a whole lot quicker. Because this goes to 0, this goes to 0, and all I have left on this side is 12. Hmm, what have I done now? These are plus 3, or I mess up, plus 3. So some of this you can do in your head, just don't do too much in your head. So that's gonna be 2 times 3 squared, so 2 times 9 is 18. You always do your exponent first and then multiply, order of operations. Plus b times -1 times 3, so -1, 3 there. And that's gonna be plus 3 times -1 is -3. So 18 minus 3 is 15. And I get -3b there. So I combine like terms, I get 15, and then minus plus a -3b. So I'm gonna subtract 15 from both sides, and I need to solve this equation for b. Divide by -3, and then b equals 1. So go back to your original where you write your partial fraction decomposition. We got a was 2, so 2 over x minus 1 plus 1, 1 over x plus 3 plus 3 over x plus 3. That would be your partial fraction decomposition. And although it took me a few pages to do it, it was easy work. I mean, the work wasn't hard, just long.
Miss,
Yes, what I do.
you're breaking up.
What was the last thing you heard?
It was when you started writing the answer. That's when you started breaking up.
All right, what about now?
You're good now.
Okay. Right, so all I did was I just took what I got for A, B, and C, and I said that this thing right here equals that. So you just plug in your A, your B, and your C, and that would be your partial fraction decomposition. And actually, that's it. That's all there is to it. That's all we're going to do. We're not going to do any quadratics. So I'm going to go into MathLab and make sure there are no quadratics in the assignment. I'll make sure of that. I'm pretty sure I did that already, but I'm going to double check myself and make sure there are no quadratics. So for repeated linear factor like this, with this problem, that would be the hardest thing you would have to do. And I didn't do 2 examples of this, and I wouldn't give you 2 of these to do probably. I probably just maybe gave you 1 of these to do in the MathLab. Because if you can do 1, you can do 15 of them. It's just a matter of knowing the process. So the only difference about this one is you end up with that square term, you end up with the C term, and you have to solve for 2 of them the traditional way. And then the third one, you plug in the ones that you already know, the A or the B or the C, or which ones you know, and then pick an X value, a different X value, and solve for the other one. Okay. Now, if you look in your book, if you have a book and you tend to go look at examples in the book, they're going to do this differently than I do, but I don't think their way is easier. I don't think it's easier to understand. So you can do it any way you want. And if you learned how to do it a different way in high school, that's fine too. I don't mind. This is how I think is the easiest way to teach it. Anybody have anything? And some of you mentioned that you wanted to come to campus possibly and get some help, and 2 of you've already come. So that was awesome. If anybody else wants to come, just let me know if you want to come Monday or Tuesday. We can set up a time. You can email me and set up a time or whatever if you want to think about it. But if you want to come to campus to get some help, we got to do this before Thanksgiving because they won't let us bring y'all back on campus after Thanksgiving. Okay. Anybody have any questions? Anything you want to?
Miss Rachel,
Yes.
can we go back to when you found C? I think I got kicked out of the thing and I wasn't able to see what you did. So I
Oh,
just wanted
okay.
to
Sure.
quick-
I sure will, and I'll even try to explain it too. So, you got all the way to where we had A and B. And so then, I mean, A and C, right? We did C first, right here. So that was just using normal methods. So I let X equal -3 and it got rid of 2 of my terms and I solved for C. And then I picked X equal 1, just normal way, and it eliminated the B and the C terms. So I solved for A. And then I said we were out of numbers that would make one of the factors 0. So I substituted the A and the C that I already had, and I chose any value for X. So what I did was I substituted 2 in for A and 3 in for C right here. So I substituted a 2 in for A and a 3 in for C. And then I had to choose another X, and I just suggested X equals 0. You can pick anything you want into an equation and plug it in for X. So once I substituted a 0 in for X, it made the math a lot easier to do. And all I had left to solve for was the B.
Okay, thank you.
Okay. And here are some more. Huh? Yeah. Someone say something? Okay, and so here's some more problems you can practice on. Which should be similar to a math lab problem. But I'm going to double check math lab like I said. I'm not going to do that. That answer the question of it gets a little messy as you work along, but I hope I worked slow enough that you can keep up with my step. So this is my final answer right here.
Miss Rachel,
Uh-huh.
you're breaking up.
All right. So all I was saying is that does anybody have any more questions on anything? I just wanted to show you on this first page, that was my final answer. So I came back and wrote my final answer on the first page there of that problem. Anybody have anything? I'm going to come back to the page, to y'all's page. All right. Well, if you don't have anything, you're free to go. If you do, you want to stay, you can stay and ask me more questions.